So without any further ado, I'd like to introduce Wouter Verhelst from NBD.
Thank you. So that's me. Welcome to Belgium, welcome to FOSDEM, welcome to my talk. Just a short question, what's NBD? Anyone in the room who hasn't heard of the abbreviation yet? Nah, I didn't think so. Well, you could think of NBD as, if you talk to an HP guy, they will say, well, that's a support thing where you go next business day, which is not what I'm talking about here. You could, if you talk to a Twitterer, they go, NBD, that's no big deal, which is true as well, but also not what I'm talking about here. No, NBD that I'm talking about is a network block device. That's the downside about three-letter abbreviations, of course. You've got multiple expansions. Network block device, we say network because it goes over TCP. We say block device because it only does block devices, not character devices, in contrast to some other networks, well, other protocols that do similar things as NBD. And it's actually a fairly easy protocol to understand and to implement, and that's what makes it so interesting, in my opinion. We could actually say support for NBD by NBD is NBD, if you just check the three abbreviations. Anyway. I did something wrong. No, I didn't do. A little bit of history. Where does NBD come from? Originally, it was written by Pavel Maček and submitted to the kernel for Linux 2.1. I think 109, but I'm not 100% sure. It's always felt to me like he did it in a sort of overnight hack. Can we do this? Is this possible? Can I do swap over TCP? Oh yeah, I can. Wow, now I've got this thing, it works. What do I do with it? Let's submit it to Linus. And he got it into the kernel. And here we are 20 years down the road and it's still there and it still works. His original idea, however, didn't actually work very well until a few years ago. But yeah, well. In the late 90s, VMware did their VMware desktop for Linux, and they shipped it along with that, they shipped something called, I'm not sure anymore what it was called, but it was something that did pretty much the same as QEMU-NBD, allowing you to mount virtual hard disks on your host system and just copy things from there. After a few years, though, Pavel got tired of maintaining some overnight hack from 5 years ago, and he passed maintenance on to two different people. For the kernel bits, he talked to Paul Clements, who'd been working on it a bit, and I did the userland devices. For the next few years, I just fixed minor bugs and tried to get it to be a bit more reliable, etc. And at some point, I managed to convince the LTSP guys that NBD might be something useful for them because they didn't use disks themselves either, and they were swapping to NBD to network, originally NFS, where NBD was written for that, so it was interesting. We also added a disconnect command because before that, all we had was write and read, and that was it. You couldn't do anything more than that. A few years later, we added named exports. Before the named exports, you could connect to a port, and if you wanted to export a second device, you had to open a second port, which was not very useful. In 2011, I finally sat down and wrote down the entire protocol spec. Like, this is how things work. Before that, people had to look at the code. Many people did that. It wasn't that difficult, but you still had to look at the code. Doing that certainly got people to understand it better and add more features to it. Paolo Bonzini certainly came up with a patch to add trim, which does the mark specific blocks in the device as no longer active, so you can just discard them from the disk. We added flush and FUA to act as a point in time where we're sure that particular writes have been completed before we move on, which is very useful if you're trying to implement a file system on top of NBD, etc., etc. 2014, some of the QEMU guys came back to me and said, look, we want to do some TLS with NBD, and originally they wanted to do an HTTPS style version where if you connect to the port, either you connect without TLS or you connect with TLS. But I prefer the StartTLS approach for reasons I'll come back to later. Was that a question? Oh no, you're just waving to me. No worries. The implementation took a bit longer. The QEMU guys implemented the StartTLS back in 2015, and this was actually the first time where a particular feature was implemented into another MBD implementation rather than mine first. So that was quite an interesting situation. I implemented StartTLS fairly recently, late December 2016. In 2015, we also added write zeros. We added structured replies to fix a problem that I'll come back to later. And Marcus Klageman in early 2015 took over for the kernel. 2016 and early this year, we added some more options, opt-info and opt-go, which allow you to figure out information about the device. We added the ability to add multiple connections to improve performance. And Josef Basik of Facebook has been taking over MBD implementation because apparently Facebook is now considering to use it for some of their internal things. I don't know the details there. Let's just go back a bit to 2003. At this point, iSCSI was fairly new. And MBD is actually older than iSCSI, which not many people know. But it was not very mature at the time. I mean, like I said, we only had read and write requests. And there was a Chinese guy who asked on an IP storage mailing list somewhere how MBD compares to iSCSI. And he got a response from a guy named Andre Hedrick. I don't know him, maybe he's in the room, maybe he's not. If you are, say hi to me. This is just a short quote, but the mail is much longer. If you have the time, you should just check the URL here. What it says here is, MBD totally lacks and will never have the ability to be easily managed in this market space. MBD is not iSCSI, it is not enterprise SAN, it is not a serious solution for SAN, it will not be adopted as SAN, it is useful in its free and open source environment, it's a great undergraduate project for SAN. I'm hoping to be able to show to you that while this may have been true at the time, it's not so much true anymore today. How does MBD compare to iSCSI? iSCSI really is a transport for SCSI. With iSCSI, you just talk SCSI over TCP. But essentially, the iSCSI standard describes how you embed SCSI commands into TCP, which means you have an HBA driver in iSCSI, which then just throws everything on the network. And then at the other end, you have an iSCSI server, which translates it back to the local hard disk through a block layer. MBD does not have such a general HBA driver. The MBD driver itself is just a layer higher. What that means is that MBD has a higher level of abstraction than does iSCSI. And the type of commands you would send over MBD are much simpler in general than the iSCSI ones. It does mean that implementing a hardware iSCSI server, where you just attach disks and it allows you to access those disks over the network, is easier than an MBD server. But implementing an MBD server is not all that hard, actually. So, a little more in-depth comparison between MBD and iSCSI. The protocol document that describes how MBD works it's fairly short. I can show you in a moment. It's a self-contained spec. What I mean with that is, if you've read the entire protocol from top to bottom, you know everything there is to know about the MBD protocol. There is an RFC that describes how iSCSI works. It's RFC 7143. It is the consolidated RFC for iSCSI. It is 295 pages. I don't know if there's anyone in the room who's ever implemented an iSCSI server. I don't think there is. I tried to look at the spec. It's just huge and impossible to read. It's extremely long. And once you've read that, you know how to embed SCSI protocols in TCP or on the network. What you don't know is what SCSI protocols to use, because that's a different document. It's not described in that one. So it shows you how MBD is much simpler. With MBD, we have an abstract concept of a block device. Essentially, for MBD, a block device is a device that allows you to read and write particular blocks of a given length at a given offset, and that's it. We don't do much more than that. With iSCSI, it's just a layer in a SCSI system. Any SCSI device, any device that speaks SCSI could theoretically be used in an iSCSI environment. You could theoretically scan a document over iSCSI. I don't think anyone would do that, but it's theoretically possible. The addressing layer in MBD, originally it was just a port name. These days we have a server host name and an export name, and that's your address. In iSCSI there is a very complicated addressing scheme. I'm not going to go into details because this is not a talk about iSCSI, and I don't have that much time, but it's fairly complicated. MBD versus iSCSI. MBD doesn't have any hardware implementations that I know of. There might exist some, but I don't think that exists. Whereas iSCSI does have that. That is one of the advantages that iSCSI does have. It is widely implemented. MBD is mostly popular within Linux and free software environments, which is not the case for iSCSI. We do have encryption with TLS these days. With iSCSI you don't, although most implementations do support IPsec. And then you can authenticate with TLS certificates or chat for iSCSI. There's the other protocol called ATA over Ethernet, which I'm not going to go into too much detail here because ATA over Ethernet isn't something that QEMU supports, whereas iSCSI does. ATA over Ethernet is fairly simple to iSCSI in theory. It uses the same abstraction, same system of sending commands over a network. It's much less popular though. There's essentially just been one company that specified it and made their devices, but they've gone bust now. So it's not really being developed anymore. It's much simpler though than iSCSI is. So if you're looking for simplicity, that might be a better option. But they don't have encryption, they don't have authentication. The protocol isn't being developed anymore. You cannot route it, which you can do with iSCSI and MBD, so there's quite a few downsides there. If you compare things in a nice looking table, at least I hope it's nice looking, if it isn't, just tell me. I also added fiber channel over Ethernet, which essentially takes all the bad bits of iSCSI and all the bad bits of ATA over Ethernet, combines them and adds some of their own, so it's not a very good looking part of the table. I think you'll agree that the two leftmost ones are the most interesting ones. MBD has a very simple protocol, as I've told you, but I haven't shown. Let me just fix that, sorry. This is the protocol spec of MBD. It's a markdown file in the GitHub repository. It is a good read, but that's it. It's not that long. If you compare that to iSCSI, like I said, it's 295 pages of ASCII text, and then you've only just read how to embed it. So the MBD protocol is much simpler and much easier to understand. It's a self-contained standard, which is not true for any of the others. It's a routable protocol. It has authentication with TLS certificates, so not if you don't do TLS. It has encryption. It doesn't have hardware implementations. I'm going to get a bit of water here. It is still actively developed, which is also the case for iSCSI, and I don't know whether that's the case for fiber channel over Ethernet. It doesn't support non-disk devices, but, and this is what makes it very interesting, there is a QEMU client as well as a QEMU server implemented that does MBD. This is not the case for any of the other protocols. We do have an iSCSI client, so if you want to boot a QEMU virtual device from an iSCSI device, that's perfectly possible. But if you want to export a device from QEMU, you can only use MBD for that. And this is what makes it so interesting for virtualization. Modern QEMU allows you to export a device while your VM is running. And we've been adding a few features that make it possible to synchronize two devices, one MBD device on a remote QEMU machine and one device locally, so you can live migrate your backend storage while the VM is running. For that, we've had to add a few features, and I'll come back to that in a minute. There are a few implementations of MBD that are free and open source, and I've listed them here. Well, I've listed most of them here. There are still a few more, but I can't list them all. The topmost one is mine. It's MBD Server, which is the reference implementation, as well as the Linux kernel itself, which only implements the client for obvious reasons. QEMU implements client and server. There is an alternative implementation by a Japanese person. I've never met him, and I forget the name again. Called XNBD. He does his own thing. He hasn't implemented most of the recent features, but it did implement a few features of its own. And it is actually being used by a particular cloud storage provider called Scaleway. Now, if you get a machine on their system, they're using XNBD. There's also MBD Kit, which was written by Richard Jones of Red Hat. It's part of libguestdev, and it allows you, with a very simple API, to implement an MBD server in like half an hour or something. So if you're using your own storage system that is not just a raw file, that is not a QEMU image thing, then MBD Kit might be just what you need to boot that boot a VM from that device. And finally, there's also Bidrig, which is an BSD clone. I think it's a fork of OpenBSD. I'm not entirely sure. And they implemented the MBD client side with the same API as Linux, so you can work on that as well. In my comparison that comes up here, I'm going to describe the most important implementations, which are the top 5, because Bidrig is fairly limited at this point in time. Actually the top 4. There are a few features that we have added fairly recently, and a few features that depend on the design of your system. So the first one is, can a server export multiple devices at the same time without requiring multiple instances of the same server? MBD Kit can't do that right now. I understand that Richard is working on getting that possible, but right now it's not possible. It is possible for QEMU and for MBD Server though. If you have a client connection that you connect to the server, currently if you just use just a single connection to your server, then you can get a bottleneck on that one connection, and Josef Vacek of Facebook has actually discovered that by using multiple connections and BlockMQ in the Linux kernel, you can get quite a performance gain. So Linux 4.10 is the first kernel that implements that feature. So if you use MBD on Linux 4.10 with MBD client 3.15 or higher, then you can use multiple client connections, and you will get quite a speed up there. QEMU doesn't implement that yet, at least not in version 2.8. MBD Kit is only a service that doesn't implement that part. There is a write zeros command that we added recently by request of the QEMU developers. The point of that is that if you want to sync from one device to another, it is useful to first be able to say, okay, there's lots of zeros here. I don't want to actually send them all over the wire. So write zeros is just some optimization that you just send a command saying there's 2 gigabytes of zeros here, just write them. TLS support is fairly recent. We implement that in MBD Server and QEMU. We don't have kernel-side TLS, and MBD Client implements TLS by proxying the TLS to the server through a little proxy, which then just decrypts it and then writes it to a Unix domain socket, or a socket pair. So you can actually connect your Linux kernel to a TLS server, but you cannot do that if you want to swap and not deadlock your system. So for that reason, the -swap and the TLS options in MBD client are, well, if you try to use them together, the system will just barf at you and say, no, that's not possible. And then the one feature that MBD Kit has over the other implementations is that it's extremely easy to add your own server backend. MBD Kit has plugin APIs for Perl, Python, OCaml, C, and a few others that I forget. I think Ruby too. So whatever your favorite language is, I'm sure MBD Kit can use it, and you can just implement reading and writing of blocks in that language, which makes it easy to export an image from, or maybe even generate on the fly if that's needed. The protocol is evolving on a constant basis. How do we do that? Originally, somebody came up with an idea, I would implement it, and we would be done. This is about 5 or 10 years ago. These days, though, before we implement a new protocol feature, there's extensive discussion on the mailing list. Then we write a spec, and then somebody writes implementation. That's either me or somebody else. And then experiences of that implementation are merged into the spec if that's needed, and then the spec is formalized and made part of the formal. Was that a question? No, okay, sure, no problem. So and then the spec is formalized, and the changes are merged into the main spec. There are currently a few outstanding protocol changes that have been discussed and for which a spec is complete, but that aren't implemented yet. The first one is structured replies. And the reason we need those structured replies is that currently the MBD protocol does have the ability to signal an error, a read error to a client, but the fields in the response where that error goes is in the header, not in the footer. So that means if you send a reply to a client, you have two options. Either you can send the header without reading your data and saying, well, all is fine, all will be fine. And then if you do actually encounter a read error, you have to drop the connection because he already said it will be fine. Or you have to allocate whatever memory the client asked for, which can be up to 2 to the 32 power, so 2 gigabytes, or for way too many memory. And then if send that to the client, which actually allows the client to DOS your server. So neither are really good options. And structured replies tries to fix that by allowing the server to split up the response into multiple blocks and having the ability to send errors at some later point in the reply. That way the client can recover from a read error, in the worst case by signaling the read error to the user space, but at least it can recover from that, and that's a good thing. Based on that structured reply, we've also added a block status option, which is something really cool. This was added by request of Virtuoso and a few backup companies, which allows us to send metadata. And the spec is very careful not to define what this metadata is. It just allows you to define the metadata context, and then in the original phase, in the negotiation phase, and then during the transmission phase, this metadata context can be queried, and then it could mean anything. It could mean things like this part of the block device has been backed up, and you need to read again for the incremental backup. Or it could mean this part of the block device has not been allocated yet, so if you try to write to it, we might give you an space. Or it could mean anything, essentially. The spec allows for extensibility there. So by using this, it would allow you to make an incremental backup of a VM that is currently running, based on a snapshot, etc., etc. And that's actually the main reason why we added this option. And there's also a second one, which is the info and go thing in the negotiation phase. Currently, if you select a named export, but the export name doesn't actually exist, there's no way for the server to say that other than to drop the connection, and Info and Go try to fix that by making that a bit more generic. We've also got an extra option that we're currently discussing. It's not, the spec isn't finished there yet, but the feature is to allow an active resize from the client. So the client can say, please make this block device now that big, rather than the size whatever it is right now. That hasn't, I mean, the spec still needs some finishing up, but it looks like it's going to happen. Right. Demo time. What time do we have right now? Oh, slow time. Essentially, where did I do that? Is that readable? Yeah. Okay. Awesome. Essentially, I'm going to run. It shows me the exports that my server has. This is my laptop, so I'm just exporting a few test devices that I do development with. The first one is called test. The second one is called test2. And the third one is called Mac image. I don't even remember what that was supposed to be. But the first one actually contains an installation of a system. So I can, with this URL format, I can tell QEMU that if I want to connect to an MBD device at that location. Sorry, of course, I have to use the right command. That should be better. So now we have a Debian booting. I don't know if you can see it, but yeah. Blah, 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 blah. It takes a moment. Oh. Yeah, it's there. It's just too big for the screen right now, I think. Yeah, that's. It doesn't fit on this small screen, but there we are. Looks like a Linux system booting. And this is running over MBD. Currently, it's just using an MBD server with a simple raw file as backend. But since the server runs in user space, it could essentially be anything. You could have something that just uses a tarball and exports from the tar file and does magic there. You can do anything you want, really. And that's the end of my talk. Are there any questions? Okay. I'm trying to get it back. Yeah.
So, probably a very stupid question, but how stable is it? How stable is this? Could I run this in a production environment?
I know of at least, well, I didn't say this. The LTSP guys, they used NBD as part of their system. The LTSP got used by Debian Edu, which got used by the Estremadura folks, and they ran it on 80,000 desktops without many issues. I think you can say it's quite stable.
Yeah, definitely.
And this was 2008, 9, 10-ish, so yeah.
Okay, thanks.
Also, the Scaleway guys use it in production on their entire infrastructure, and it seems to work fine for them. So, yeah, you can use it in production, definitely. Please do. Yeah, there's one over here as well.
I was wondering, regarding the overhead of this, performance-wise, how much MBD is affecting network performances?
Yeah, performance is a very good question. And I actually did run a few tests. I ran iSCSI and ATA over Ethernet and MBD two implementations of MBD. First on my home server, which runs ZFS on 5 devices and has a 1 gigabit network. And the second time at a customer site where they run ZFS on 14 disks and have a 10 gigabit link between the two nodes. And I could not see any difference between the four protocols. Well, nothing statistically significant, really. There were some differences, but I don't think it has performance issues as compared to I2C. It looks fine to me, but I couldn't get, I tried to make a graph for that and add it to my talk, but I couldn't show it in a reasonable way, so I couldn't do that. But I can give you the numbers if you're really interested. All right? Anyone else? You had a question earlier too.
We have one here.
One there. Okay, sure. Go ahead.
I was actually going to ask about latency, not just bandwidth.
Well, it runs on top of TCP, so if you have a TCP issue, then you have an MBD issue. But essentially, the overhead is very small, and we have shown that it's faster than using a loop mount on an FS device because you've got way less overhead. The packet, I didn't add that because it would get too technical, but the packet, the request packet is, I think, 5 fields, and the response packet is that much field. It's actually 3 fields worth of data, so it's fairly small and fairly low overhead. So latency is fairly low, but it depends on the size of the request, of course.
Yeah, I wonder about scalability. How do you do this with one TCP endpoint? Do you have in mind something kind of about load balancing that and referring to a cluster? Can you do something like that?
So the protocol spec actually defines what happens if multiple clients connect to the same device through various means. So we added that before because of the multiple TCP connections to the same server. But there's nothing in that spec that requires them to be a single server. My implementation doesn't implement that. The kernel doesn't check that, but you can essentially, if you wanted to, if you had several servers which had the same backend somehow, or which synchronized somehow, and which synchronized on the same synchronization points that are defined in the MD protocol, then you could perfectly well load balance on several servers. I'm not aware of an implementation that does that, but there's nothing theoretically that would stop you from doing so if you wanted that. Right? Right?
Any experience from running RAID on top of MBD?
People have done that successfully, yes. RAID on top of MBD. You can use software RAID on top of MBD, and actually the MD RAID maintainer in Debian has done that at some point. I don't think for a very long time, but it's possible to tell the MD RAID layer in the kernel to say only use this device if all else fails. So if you do that to the MBD device and not to the local disk device, then you can use it as a sort of weird way to back up things. But it works. Go ahead.
I think I ran into a problem that the client doesn't get some kind of a serial number like a normal disk has. Do you know what I mean? So on the client side, you've got the driver with the block device itself. And then there are means to read out the serial number of a real disk. And I think the protocol doesn't support this somehow, or the service should generate some, I don't know, random.
There is indeed no way to export a disk serial device through MBD, because MBD doesn't do disks, essentially. It just exports a block device with the size of an offset. If you have a real need for that in some way, I'm sure we can come up with some protocol extension to do that, but currently we don't have that. What I do know, though, is that there are some protocols like NFSv4, 4.1, there you have a serial number on the block device, and that should theoretically work with that too. But no, it doesn't add a serial number. We could easily add it if we wanted to. It's not a problem. Right.
If you resize the source image file or block device, does that propagate through to the client's kernel, or do you need to do something special? So
you resize the device on the server side. Currently it doesn't, but the active resize, the intent is that it would do that, would have the ability to signal that too. But currently it doesn't. So no. Any more questions? Right there. Many questions. Either that means my talk should have been better, or people are very interested. That's cool. I don't know. Go ahead.
So can be used with multipath?
With multipath?
Yeah.
So the multipath I was talking about. I think of BlockMQ. I haven't tried that. but I don't see why not. If you can tell multipath to track to 1 and 2 MBD devices, in theory it should be possible.
Okay.
I haven't tried it myself.
Second question, sorry. I have read about trim support, so I believe...
About what, sorry?
Yes, tools like Chemo, Sparsify could be used. Are that working to retrieve the space?
Oh, right. So we did add the block info thing, and that will tell you, that will have the ability to say whether the file is sparse or not. If the server supports it, and if the backend, if the server knows enough about the backend, because the server might still be a VM, we don't know that. We can't guarantee that the information is correct, but there is a means of signaling, let's put it that way, of signaling that there is, whether or not the backend is sparse, yes. Go ahead. 5 minutes. Any more questions? Yeah, over there.
Hi, if you've not specified the meta information, do you have, or do you expect some, how do you expect that different clients work with this meta information?
I'm on the wrong side. Let me just go to the actual spec maybe, if I have it. No, I don't. Here we are. Here. So, no, we're too far away. Anyway, so essentially the idea is you negotiate a metadata context during the negotiation phase. And the metadata context is a namespaced string. So you say this namespace can be QMU, can be spec, can be base, whatever. Column, and then something in that namespace. So the namespace should have its own spec somewhere, and that will define how it works. And then during negotiation, you can say, I want to see this particular metadata context, and I want to use it. And then during the actual phase where you want to read the transmission phase, where you want to read the information, you get a metadata context ID that refers to whatever you negotiated at first. So it allows people to add as many contexts as they want. So it should be fairly flexible. There are two contexts, there's one context in the spec, which is for sparseness. That is defined in the base spec itself. But you can add as many as you want. And QME is probably going to add a few, as I understand. More questions? Yeah, go ahead.
In enterprises, usually you have the assumption the storage is always up and never break.
Right.
There is some support for NBD clustering or something like that?
Not at the NBD level. There has been a unreliably implemented option to allow a client, when the connection drops, to maybe recover. But that hasn't been very reliably implemented in the kernel. Theoretically, you could do that, but it is some area that I do think we need to improve on. It's not quite there yet. But as long as your server remains up, all should be fine. With the multi-connection stuff, I just saw a patch pass by yesterday, or maybe it was this morning, not sure, from Joseph, where if you've got like 4 connections and one gets patched, we move on with just 3. If you use multipath on top of MBD and one of them drops, then you still have another connection. So there's a few options there, but essentially it's not been well defined what happens if the connection drops unexpectedly. The answer is don't drop it, but yeah. More questions? That should be perfectly fine. Yeah. No more questions? Almost out of time too, so I'm going to leave it at that then. Thank you for your attention. Thank you for your interesting questions. See you next time.